Hi. Yesterday evening, I was scrolling through YouTube videos and YouTube suggested me a video about a math problem. And because it was late and I was tired, for the sake of relaxation, I said that I'm gonna solve this problem. The question was this one. It's an interesting one. You can also pause here and try to find a solution for this. So I spent 20-25 minutes to completely solve the exercise. Of course, at first look, you can immediately guess the solution, but to prove that this solution is the only solution, it takes a little bit of time. At least it took me a bit of time. So usually after solving these type of puzzle shape exercises, you have to brag to yourself and say something positive to yourself and smile. So I said, Muhammad, look, an old lion is still a lion. So even though he's slow, but still he can bite. Anyway, it took me back to the time when I was at high school and I was preparing for National Math Olympiad competition. And at that time, I studied a lot of books. One of the first book was about inequalities, which I studied it, I think when I was 14 or 15. In one chapter, the book had this exercise, and there was no solution for the exercise. Now, normally these type of infinite series, I knew how to deal with them. But when I tried on this, I spent maybe about an hour and I could do nothing about it. At the time, I had clue about how to deal with an infinite series. For example, you consider it as a constant and then power 2, rearrange it, and eventually you find a solution. Or, for example, you multiply it to some number, you add or subtract some number, regroup it, and eventually you manage to put the term next to each other. They all cancel out, and you have the solution. Or sometimes you compare each term with another fixed term and eventually regroup them. You figure out the solution. But this exercise was a bit different because you see the numbers are changing. They are inside multiple of squares. You don't have access to them. It's tough, and it's going also to infinity. So I could not solve this exercise in the first attempt. But I told myself that if you are going to be the best in the country, you must be able to solve this exercise. This is for sure a simple exercise. It cannot be difficult. So I promised myself that I would not search for a solution because the book also didn't have the solution. And then every week, maybe every 10 days, whenever I was tired, I get back to this question and tried a few minutes, 20 minutes. Of course, I could not solve it. So this process continued up till 3 months after I started to work on this exercise. And in one day, so about 3 months after I started, I rewrote this exercise a little bit different. And then within several minutes, I managed to find a solution. So let's see the solution. Okay, so the first part is the main question. Instead of having this going to infinity, which really blocked me from working out this exercise, I decided to write a general term of this series, which basically we have n. And then if I can prove this for any n, I can simply shift n to infinity and that basically becomes equal. So I'm going to prove this exercise. Now, of course, this one, we know also some simple inequalities. So n times n plus 2 is less than n plus 1 power 2. So this is obvious. This is n2 plus 2 and this is n2 plus 2 n plus 1. And of course, if you have a number larger than 1 and you power it to something positive, it will be always larger than 1. So with these two in mind, the solution comes in a minute. So this is the main series, and then we just multiply it to a number. Actually, in the first attempt, I didn't put this number. I actually directly put the number here, but I knew that this will just make the series a little bit larger. So this must be larger than this. But then for the sake of clarity, I just pulled it out here so that you see. So anyway, we multiply here by n plus 2, and we know that this one is less than n plus 1 power 2, and then obviously that one comes out. And now we have n plus 1 times n minus 1. And these two, again, will be less than n2, and again, this one comes out. And basically, you can see that the series is getting simplified from the right side toward the left side. So the process will continue. Eventually, we get to 4 times 6. This one that is less than 5 power 2. 5 comes out. 3 times 5 less than 4 power 2. And then this is 2 square root of 2, which is less than 3. So this is basically the end of the solution. Now, this actually stayed with me as an example that if you are persistent and you don't give up, it is very likely that you reach to what you want. I actually use this example for my students to tell them that they should try hard, they should be persistent. And I say that, oh, when I was young, there was one question and I had to spend 3 months, tried every time. to eventually find a solution. So that was the story of this question, and that's why I never forget it. Thanks for watching. Bye.